Okay, so our lesson that is on chain rule. If y is a function of u and dy du exists, and u is a function of x and du dx exists, and y is a function of x and dy over dx exists, and is given by dy over dx is equal to dy over du times du over dx. As you can see here, if you can see here, dy over du and du over dx, if you are going to cancel du, then still you have dy over dx. So we have here the symbol of partial derivative. So when we can have a partial derivative. So if u is a differentiable function of x and y, so we have here u is a function of x and y, and x is a differentiable function of r and s, and y is a differentiable function of r and s. So we will have a partial derivative for this case. So the symbol of partial derivative is this one. So for example, in our given, our u is a function, differentiable function of x and y. So, and then our x is a differentiable of two variables, r and s. And y is a differentiable function of two variables, that is r and s. So, we will have partial derivative for here because for x and y, we have two variables. Okay. So, example here, we have an example here. If you are going to find the partial derivative of u with respect to the partial derivative of r. So, to find the partial derivative of u with respect to r, so all you have to do, what are your two variables involved in your equation? So, example, that is x and y. So, we will have du over dr. Du over dr. Then you will have dx, then dx, then dy, then dy. So, all partial derivative. Okay, I'm going to show you an example of u as a differentiable function of, differentiable function of x and y. So, we have here u, differentiable function, a differentiable function of x and y. Okay, given u is equal to ln the square root of x squared plus y squared. This is a differentiable function of x and y. When you say differentiable function, you can find the derivative of x, you can find the derivative of y. Okay, so we have here, wherein our x, that is given as differentiable function of r and s. So meaning, okay, meaning the given for x, you can find the derivative of r, you can find the derivative of s. So your variable, that is r and s. So example here, x is equal to r e s. So x is a differentiable function of r and s. So we have also, our y is given as a differentiable function of r and s. Example, y is equal to r e negative s. So y here is a differentiable function of r and s. So in our given for y, we have two variables, r and s. When you say differentiable, that means you can find the derivative of r, you can find the derivative of s. So, differentiable. Okay. So we have here the example. U, okay, U is equal to differentiable function of, is a function differentiable of x and y. X is a function differentiable, it's a differentiable function of r and s. So do with y, a function, it is a function differentiable for r and s. So example here, u is equal to ln the square root of x squared plus y squared. X is equal to res, y is equal to re negative s. So here we are going to find, okay, partial derivative, because we have two variables for your x and y, two variables. So when you have two variables, we can find the partial derivative. Partial derivative of u with respect to r, partial derivative of u with respect to s. So how to solve for the partial derivative? Partial derivative of u with respect to r. Okay? How to write that one? So you write first du over dr. Partial derivative of u over dr here. Because you can have like that. Du over, then you will have dr. Then you will have, you're looking for du. Du over dr. Okay. So, since you're solving for dr, okay. So, for r, we have our variables for you, that is x and y. So, differentiate this one with respect to r. So, for this time, our variable will be using the variable r. So, therefore, you will have here two variables, x and y. So, you will have dx, dx. Then, you will have dy, dy. So, that is now your formula. Okay. Next, you're asked to solve for partial derivative of u with respect to s. So, du with respect to variable s, du ds. So, how to make the formula? So, du ds, you're solving for du ds. So, du over ds. Okay. Plus du over ds. So, then, what are your two variables? X, y. Okay. So, you will have to do dx over dx. Then, you will have dy over dy. So, this one, okay. So, if natong given, this is dx. Then, this one is dx. Okay. Okay. The first example, we are going to find the partial derivative of u with respect to r and partial derivative of u with respect to s, given ln the square root of x squared plus y squared. X is equal to res and y is equal to re negative s. If you are going to find for the partial derivative of u with respect to x, so you will have x over x squared plus y squared if you are going to solve that one. The partial derivative of u with respect to y, this time, if you are going to find the partial derivative of u with respect to y, so we will consider x as a constant. That's the reason your answer will be y over x squared plus y squared. Then you will have partial derivative of x with respect to r. So we will have, with respect to r, es, that will be considered as constant. So derivative of x, partial derivative of x with respect to r, that is equal to es. Then, we will have partial derivative of x with respect to s. Okay, with respect to s. So, this time, s is your variable, r is your constant. So, therefore, you will have re to the s. Then, partial derivative of y with respect to r. Okay, with respect to r, r is your variable, e negative s as your constant. So, you will have e negative s as your answer. Then partial derivative of y with respect to s as your variable, r is constant, so you will have r, negative r, okay, negative r, e negative s. Okay. So, example here, if you are going to find du dr, the partial derivative of u with respect to r, our formula, that is du over dr, so dx dx, du over dr over dy dy, okay, partial derivative. So, du dx, so as we have solved, the partial derivative of u with respect to x, that is given as x over x squared plus y squared. The partial derivative of x with respect to r, that is e to the s, and y, okay, partial derivative of u with respect to y, that is y over x squared plus y squared. Then partial derivative of y with respect to r, that is e to the negative s. So you can solve that one. So simplify that one. Your LCD is x squared plus y squared. So combine this one. That's the reason you will have x e to the s plus y e negative s over x squared plus y squared, having x squared plus y squared as your LCD. So that is now your final answer. Okay, when we are going to solve for du over ds, that is partial derivative of u with respect to s, we have solved a while ago that du over dy, that is y over x squared plus y squared, and the partial derivative of y over ds, that is negative r e negative s, plus the partial derivative of u over dx, that is x squared plus y squared, and the partial derivative of x with respect to s, that is res. Then we can simplify that further. X squared plus y squared as your LCD. Then r is common, so you will have r. Okay. We will write first the positive, so you will have x r e s, so x e s, that's the reason, that one. Then negative minus y e negative s. Okay, that is your final answer. Okay, the next example, class, we have u is equal to xy plus xz plus yz, wherein x is equal to r, y is equal to r cosine t, z is equal to r sine t. So we are going to find the partial derivative of u with respect to r and partial derivative of u with respect to t. Okay, so therefore, solution here, we are going to solve for du over dr. If you are going to solve for du over dr partial derivative, so you will have du over dr, du over dr, du over dr. What are your variables? X, y, and z. dx dx, dy dy, dz over dz. Then you will have that formula. How many variables you have in your equation? That is the number of du over, example, du over dr here. So because we have three variables here, x, y, z, that's the reason we have 1, 2, 3. Okay. So, in our given, we have u is equal to xy plus xz plus yz. Du over dx, meaning we are going to find the derivative of u with respect to x. With respect to x, so meaning x is our variable. All others are constant. So therefore, yz, that is becomes 0. Derivative of yz, that is 0. Why 0? Because yz, that is considered constant if your variable is x. So therefore, the derivative of u with respect to x, that is y plus z. Then we are going to have dx over dr. dx over dr, derivative of r with respect to x, that is 1. Derivative of u with respect to y. Okay, this time, y is your variable. X and z are constant. So that's the reason we have x plus z. How about xz? That becomes 0. Why 0? Because that is considered constant if your variable is y. So dy over dr. dy over dr, meaning r is your variable. Cosine t, your t is constant. So therefore, derivative of y with respect to r, that is equal to cosine t. Then we will have du dz. So here, we are going to find the derivative of u with respect to z. So this time, xy, that is considered as constant. So derivative of xy, that is 0. Derivative of xz with respect to z, that is x. Derivative of yz with respect to z, that is y. That's the reason you will have x plus y. Derivative of z with respect to r is constant, r is variable, t is constant. That's the reason derivative of dz over dr, that is sine t. To simplify this one, you are going to substitute the value of y. Y is equal to r cosine t. So r cosine t, z is equal to r sine t, plus, okay, x, that is equal to r, z is equal to r sine t. That's the reason you will have r sine t. Cosine t plus x, that is equal to r times sine t, so sine t, plus x, that is r, plus y is equal to r cosine t, so r cosine t times sine t, so therefore you will have r sine t cosine t. And then, okay, so we have multiply cosine t inside, so you will have r cosine t, then you will have r sine t cosine t, then combine like terms. So when you are going to combine, we can combine, okay, r cosine t, okay, you have r cosine t, so therefore you will have 2r cosine t, right? Because you have r cosine t, r cosine t, so 2r, so you will have 2r cosine t, and then you will have r sine t, then you will have r sine t, so therefore you will have 2r sine t. So this is the one. I factored out 2r. Then here you will have r sine t cosine t. So r sine t cosine t. We have r sine t cosine t. So you have 2 sine t cosine t. So you will have 2 sine t cosine t. I factored out r. So if you are going to look at this one, 2 sine t cosine t, that is from a double angle formula. Sine 2t, that is equal to 2 sine A cosine A. 2 sine A, sine 2A, that is equal to 2 sine A cosine A. So that's the reason, sine t cosine t, 2 sine t cosine t, that is equal to sine 2t. So our final answer, that is equal to 2r cosine t plus sine t plus r sine 2t. Why sine 2t? That is from double angle formula. Sine 2a, that is equal to 2 sine A cosine A. So, okay. Okay, next example, we are going to find du over dt, partial derivative. So, we are going to find du dt, du dt, du dt. Your variables, you have 3 variables, x, y, z. Okay, that is how you're going to form your formula. Where our given u is equal to xy plus xz plus yz. X is equal to r, y is equal to r cosine t, z is equal to r sine t. So, we are going to find the partial derivative of u with respect to t. So, du dx, derivative of u with respect to x. So, yz is constant because your variable here is x. So, therefore, you will have y plus z. Derivative of x with respect to t. You don't have t in your given. X is equal to r. That's the reason derivative of x with respect to t, that is equal to 0. Variable is t. Given is r. So, therefore, r is a constant. Derivative of a constant, that is 0. Derivative of u with respect to t. Okay. Derivative of u with respect to y. Derivative of u with respect to y, here y is your variable, xz is considered as constant. Derivative of u with respect to y, therefore, is x plus z. So that's the reason you will have x plus z. Here, derivative of y with respect to t. Here, r is considered as constant. T is your variable. So, derivative of cosine t, negative sine t. That's the reason you will have negative r sine t plus du over dz. Du over dz. X and y is considered as constant because your variable is z. So, derivative of u with respect to z here, this is 0. So, therefore, you will have x plus y. This one. Derivative of z with respect to t. With respect to t, r is constant. Derivative of sine t, that is cosine t. That's the reason you will have r cosine t. So, after that one, multiply. So, this one is 0. So, this one. Multiply r sine t. Distribute that one inside. So, r sine t. X is equal to r. Okay, r. Z is equal to r sine t. Okay, that one. Negative r sine t plus x is equal to r. Y is equal to r cosine t. Then r cosine t. Then after that one, multiply that inside r. Multiply r inside. Okay, distribute. So this one, distribute r cosine t inside here. So that's the reason you will have r times r, negative r squared sine t. Negative r times r. So negative r squared sine squared t. Here you will have r times r squared cosine t plus r times r squared times cosine squared t. Why cosine squared? Because cosine times cosine. So cosine squared. And then after that one, you combine like terms. R squared. Okay. We will combine cosine t. Okay. Cosine t and sine t. So cosine t minus, why minus? Because it's negative. Minus sine t. Factored out r squared. So I factor out r squared here. Plus, okay, combined with exponents. Cosine squared, sine squared. So I have here r squared, cosine squared, okay, cosine squared minus sine squared. Okay? So from our identities, double angle formula, cosine squared t minus sine squared t, that is equivalent to cosine 2t. So that's our final answer. Therefore, partial derivative of u with respect to t, that is r squared cosine t minus sine t plus r squared cosine 2t. Where is cosine 2t from? That is from double angle formula. Cosine 2t, that is from cosine squared t minus sine squared t. Okay?